Hello everybody, I'd like to welcome you to our 25th video in the pre-algebra playlist, and in this video we're going to go over the concept of prime factorization. Now before I begin going over prime factorization, I would first like to go over the definition of factor. Some number or some expression is known to be a factor in mathematics if, when you divide some another number or some another expression by the first number or the first expression, will yield you a remainder of 0. Later on in the video series, we might get to an expression being a factor, but that's for later on. So if you're thoroughly confused by this definition over here, let me give you a few examples. Let's say I have something such as 18 divided by 9 equals 2. In this case, the number 9 is an example of a factor of the number 18. This is true because when I divide the number 18 by the number 9, I will get an answer with a remainder of 0. Similarly, if I have something such as 18 divided by 2 equals 9, in this case over here, the number 2 is an example of a factor of the number 18 because when I do 18 divided by 2, I don't get a decimal answer, but I get a whole number. So basically you might be wondering, is it possible for some number to have more than one factor? Well, yes, a number can have multiple factors. Every number has at least two factors. The first factor of any number is the number 1, and then the another factor is always the number itself. Now let's work out all the factors of the number 18. We know that 18 divided by 1 will give me 18. Since 18 is a whole number, 1 is a factor of 18. When we do 18 divided by 2, I'll get 9. And since 9 is a whole number, I know that 2 is a factor of 18. When I do 18 divided by 3, I will get 6. And since 6 is a whole number, 3 is a factor of 18. When I do 18 divided by 4, I will not get a whole number. So 4 is not a factor of 18. The same goes with the number 5. Now if I do 18 divided by 6, I will get 3. And since 3 is a whole number, 6 is a factor of 18. Also, if I do 18 divided by 9, I will get 2. And since 2 is a whole number, 9 is a factor of 18. 18 divided by 7 and 18 divided by 8 will not give me whole numbers. And lastly, 18 divided by 18 will give me an answer of 1. And since 1 is a whole number, 18 is a factor of 18. The numbers 1, 2, 3, 6, 9, and 18 are all of the factors of 18. So you may realize by now that if you're asked to find a factor of a number, it might become a tedious process, especially if that number is a big number. So before we go over the quick and efficient way of figuring out all of the factors of any number that you encounter, let's go over a couple of definitions that will help you out with the process. The first definition that we will go over is that of a prime number, and then the second one is that of a composite number. Prime numbers possess a special interest for all mathematicians out there. There are special fields in mathematics that are completely dedicated to the study of prime numbers. So what are prime numbers? Well, a prime number is any integer that is greater than 1 that has only two factors, the number 1 and the number itself. So what is an example of a prime number, and how many are there? Well, there are indeed infinitely many prime numbers, so we can't really sit here and calculate all of them. But let me still give you a few examples of prime numbers. One of the examples of prime numbers is the number 3, because the number 3 is not divisible by any other number besides the number 1 and itself. Another example of a prime number is the number 5. Because 5 is not divisible by any other numbers besides 1 and itself. Another example is the number 7, because 7 is not divisible by any other numbers besides 1 and itself. 9 is not an example of a prime number because 9 has a factor of 1, the number 3, and itself, which is 9. 17 is an example of a prime number. because 1 and 17 are the only factors of the number 17. Now you might be wondering, well, can any even number be a prime number? Well, yes. The only even prime number out there is the number 2, because 2 has factors of 1 and itself. Besides the number 2, all other prime numbers will be odd. Basically, those prime numbers will not end in the digits 0, 2, 4, 6, or 8. On the other hand, not all odd numbers are prime numbers. So let me just quickly list the first 10 prime numbers so that you just get a better understanding of what prime numbers are. So now that you know what prime numbers are, let me just quickly go over one more definition before we actually do prime factorization examples. Now this definition right here is quite simple. If a number is not a prime number, then it is known to be a composite number. A composite number is basically any number that has more than 2 factors. Basically, it has at least one more factor besides the number 1 and itself. So an example of a composite number is the number 18, like we saw in the previous page, because 18 has multiple factors besides the number 1 and itself. So on the next page now, let's go over the examples of prime factorization. So basically the whole concept of prime factorization, or figuring out all of the prime factors of a composite number, is that any composite number can be rewritten as a product of multiple prime numbers. So let me now do an example of a prime factorization problem. Let's say I want to figure out all of the prime factors of the number 16. What I need to do first is figure out what is the smallest prime factor of the number 16. Well, if I do 16 divided by 1, that will give me a whole number of 16. So I know that 1 is a factor of 16. But 1 is not a prime number, because a prime number needs to be greater than 1. On the other hand, if I do something such as 16 divided by 2, then I will get 8. And I know that since 8 is a whole number, 2 is a factor of 16. And I know that 2 is a prime number. So what I can do now is do a little tree diagram over here. On one branch, I'll write the factor itself, which is the prime number 2. On the other branch, I'll write down the number that I need to multiply the prime factor by to give me the 16. So 2 times 8 will give me 16. In the next step, I need to figure out all of the prime factors of each of this branch. I cannot figure out any more prime factors for the number 2 because the number 2 is in itself a prime number. But on the other hand, I can figure out the prime factors for the number 8 using the similar procedure like I did with the number 16. So I need to begin again by figuring out the first prime factor for the number 8. In this case, 8 divided by 2 will give me the number 4. And since 4 is a whole number, 2 is a factor of 8. So I get 2 times 4 equaling 8. Now again, 2 is a prime number. So that's it for this branch over here. I need to do one more branch to figure out all the prime factors for the number 4. In this case, 4 divided by 2 will give me 2. I can write this down over here like 2 and 2. I have this number over here, this number over here, this number over here, and this number over here. These 4 numbers are all prime numbers, even though they are the same prime number. And if you think about it, when I do the product of all of these 2's over here, I will get the number 16. For example, if I do 2 times 2 times 2 times 2, because there are 4 2's in my branch over here, I will get 16. So this right here is an example of a prime factorization problem. Another way of writing the prime factorization for 16 is simply using exponents and writing this as 2 to the power of 4. If you're confused, let me do another example. This time, let's say I have some number such as 36. Now, what I can do first is figure out what is the first prime factor of the number 36. In this case, when I do 36 divided by 2, which is a prime number, I will get 18. And since 18 is a whole number, 2 is the first prime factor for the number 36. So I draw a little branch, and then I write the 2 on one branch and 18 on the other branch. I need to move on to 18 and figure out what is the first prime number factor for the number 18. In this case, 18 divided by 2 will give me a 9. So I do a little branch and I write 2 on one branch and 9 on the other branch. I move on to the number 9 and figure out the first prime number factor for the number 9. In this case, 9 divided by 2 is not the answer that I'm looking for. Moving on, I know that 9 divided by 3 will give me 3. So I can draw a little branch and rewrite 9 as 3 times 3. I have this 2 over here, this 2 over here, and these two 3's over here. So I can rewrite 36 as 2 times 2 times 3 times 3. Another way of writing this over here is to use exponents and write this as 2 to the power of 2 times 3 to the power of 2. So this right here is the answer to the prime factorization for the number 36. In this example, let's say you want to figure out the prime factorization for the number 100. You know that the first prime number factor for the number 100 will be 2. So I have a little branch over here, and then I'll write the 2 over here and the 50 over here. The first prime factor for 50 is the number 2. So I draw a little branch over here and I do 2 times 25, which will give me 50. The first prime factor for the number 25 is the number 5, because 25 divided by 5 will give me 5. So I do a little branch over here and I realize that I'll put 5 on one branch and 5 on the other branch. One way to write the prime factorization for the number 100 is to simply write down 2 times 2 times 5 times 5. Another way is to simply use exponents and write this as 2 to the power of 2 times 5 to the power of 2. This right here is the prime factorization for the number 100. So that's it for this video. I hope you learned how to do prime factorization properly, and I hope you keep on working hard, and I'll see you in the next video.